uh, this one from the tenor key, another tenor board. This is the tenor board, okay? 8086 microprocessor tenor board. This is the using this tenor kit using the microprocessor, built in the microprocessor 8086, and another tenor kit is the 8088 tenor kit. This, okay, this available are laboratory. Okay, so this tenor kit, this is the keyboard, and this is the microprocessor. Okay, and this 8255, this is the peripheral, this another controller, like this. Okay, so, and this is the power uh, section. Okay, this is the power section. And this is the power adapter, power supply unit. This is the specification. processing system. These both tenor board are available in our laboratory. Okay, this is the 8086 tenor kit and this is the 8088 tenor kit. We are using the 8088 tenor kit. Okay, all are clear?
Yeah.
New parts of the road is driving the class. Okay, so all are clear? This is the 8088 microprocessor tenor kit. You know that 8086 microprocessor and 8088 microprocessor almost same. Clear? All are almost same. This is the only this difference. This is the 16-bit address and 8086. This is the 20-bit address. Okay. So and this is the 16-bit microprocessor and also 8086 16-bit microprocessor, all are same. Okay. So now we start last class. Okay. Okay, we already discussed our assembly language programming code. Okay, you know that suppose this is the simple program established our trainer board. This is the trainer board. Okay, like this. This is the 8088 trainer board. Suppose so we are just addition. Okay, suppose color will be red. Okay. So suppose 3 9 plus 5a. Now what's the result? This is the hexadecimal code. You know that hexadecimal 1 bit is equal to binary 4 bit. Okay, all are clear? Anyone response,
Yes.
please? Okay, thank you. So this means this 3 means binary 0 0 1 1 and 9 means 1001. Okay, all are clear? This, and A means 5. Suppose 5 means 0, 1, 0, 1. This is the 5. And A means 10, 1, 0, 1, 0. Okay, so this your addition system. This is the binary and this is the hexadecimal. Okay. So
Okay.
our microprocessor are programming this the assembly language code. These microprocessor are establish the assembly language code. Okay. Assembly language code. This is the short form of our English language. This called mnemonics. Suppose addition, this is the short name add. Movement, this is the short name move. Okay, subtraction, this is the short name sub. Okay, compare, this is the comp. Okay, compare, this is the short name using our this language. This is the suppose you know that our register structure 8086 register structure, you know that 1 2 3 4, this is the general purpose register. Okay, this is the AX, this is BX, CX and DX. Clear?
Yes.
And this name AH, this is the AL, this is the accumulator high and this is the accumulator low. This is the BH, BL, CH, CL and DH, DL. Okay, this our register structure. If we use 8-bit, then any using this A is AL, B is BL, C is CL and D is DL. But you are using the 16-bit, this not using, this the using AX, BX, CX and DX. Okay. So this is the 8-bit code. This is the this 4, 8. This is the 4 and this 4, 8. Okay, this also 4, 4, 8. So we are using any register. Okay, so this is the formula. At first, this data transfer, this register, this data transfer to our register. This code MOV, move. MOV called move. Suppose we are transfer the L register. Okay, so L at first L, comma this data. Okay, this data 39. This is the one instruction. This called this 39. This data transfer to L register. Now our L register data 39. Okay, all are clear. And suppose
Yes, sir.
this data transfer another register. So this call this the program move. Suppose CL comma 5A. So now our CL data, this register data is out the 5A. Okay. So at first data reserve or data transfer to register. Then now our instruction, this is the addition. So this is the code add. Add means addition. Add L comma CL. AL register comma CL register. You know that AL register data already reserved the 39 and CL data 5A. So AL comma CL means this data and this data addition, and this also this data transfer to full result transfer to AL register. So our previous data is erased. Now our result is this position. Okay, so this your coding. Now finish code. This is the halt. Halt. So this is the assembly language code. Okay, all are clear?
Yes, sir. Yes, sir.
এই মিথুন তোমরা রেসপন্স করো না কেন? আছে মিথুন? দেবা, মিথুন, রিজভি, তোমরা কি বুঝতে পারছো?
জি স্যার।
আমার আরেকবার দেখতে হবে স্যার, ভিডিও দিলে দেখবো স্যার সময়।
এখন কেন দেখতে পাচ্ছ না?
এখন স্যার সব দিক দিয়ে আলো জ্বালা লাগতেছে, গরম গরম, মাথার মধ্যে কাজ করতেছে না স্যার।
কেন মাথা বলতে পারছো না? আমি তো কঠিন করে কিছু বলিনি।
না স্যার, সহজ করে বলছেন, তখন বলছি না, এর কারণে মাথা ঢুকতেছে না। আমি দেখবো স্যার, অত সমস্যা না স্যার, হালকা এটা বুঝবো স্যার।
Suppose we are using the 16-bit addition. You know that our register, this your sorry, this our register structure. This is the AX, BX, CX, and DX. Okay, this is the AX, L, BX, BL, CX, CL, and DX, DL. Now our suppose addition 5A03 to 9B8. Okay, this addition. So now our code, explain any one person. At first this data transferred to our register, so code. Anyone? Ibrahim,
Yes, sir.
explain this code.
Uh,
First move,
now you use
move.
101.
No need the binary. Okay.
Okay.
Directly transfer to this data transferred to, at first this data transferred to one register and this data transferred to another register. So our code, transfer code, move. A move.
Move
Move.
AL.
No, this not A.
AH.
This is the 16-bit. 16-bit. 1, 2, 3, 4. 16-bit means must be use AX.
Okay.
If you use 8-bit program, then AL, AS, BL, BA is no problem. This is the 16-bit. So this is the 8-bit and this is the 8-bit. So full needed. Then this the code is AX. Clear?
Yes, sir. Clear.
So our code AX. X, comma,
5A03.
Okay, this data transferred to our AX register. This register. This register.
Yes.
Now this register data. Now this register data 5A03. Okay. And another move. Another, explain. This data transfer to another register. So move.
BX, sir.
DX, CX, DX, any, no problem.
Okay.
DX. Comma.
Okay.
29
B8.
8. Okay.
Yeah.
Now our data transfer finished. This is the BX. So BX data 29
Yes.
B8. Okay. So now this is the finish. Now our addition. So add. If you use subtraction, then sub. If you use multiplication, then mul. Okay, MUL.
Okay.
This means multiplication. DIV, div means division, and SUB, sub means subtraction, and add means addition. This force. Okay. So
Okay,
add.
AX plus
A
BX.
X, comma
BX.
BX. So this means AX registered data. This registered data means this data, and BX means this
Yes.
data. This data and this data addition. And finally, result is transfer. Result is transfer this position, this AX. Now this not previous data is erased. Now your result. This result means 8 and 3. 8 and 3 our result. 11. 11 means B. Okay. This also B. Okay. B. And this the 10 and 9 means 19. Then 16, 17, 18, 19. These are 3. Okay. 3 and these are 1. And this 3 and 5. 5 and 3, 8. So this is your result. So now your final result, this result 8, 3, B. So B. This result transfer to this position. Okay, all are clear?
Yes, sir.
This is the hexadecimal addition.
স্যার আর একবার স্যার একটু যদি বলতেন
কোনটা?
এই স্যার যে অ্যাডটা অ্যাডিশন স্যার
অ্যাড মানে হচ্ছে এক্স রেজিস্টারের ভিতরে যা আছে, এক্স রেজিস্টারের ভিতরে কি আছে? এই ডাটাটা, this data reserve this X register. Any data. Previously, we are submitted this data transferred to this register. So X register, our data is this, and BX register data this. So now addition X comma BX means this data and this data add, and finally this result is transferred to X register. Okay. This result is transferred to X register. Our previous data is erased, then newly added our result. Okay, this register. Clear?
থ্যাংক ইউ স্যার
BX register আর AX register এর ভিতরে যোগ করে this the left side, যে left side এ থাকবে সেখানে কি হবে? রেজাল্টটা জমা হবে। All the transfer position is left side, not right side. Right to transfer left side. Suppose this result transferred to another register. Now this result transferred to DX register. So our command, explain this be
DX X BX
move
DX
X
BX
comma X. Good. So this result transferred to DX register. So this X comma DX comma AX, not X comma DX. Left side, this is the transfer position. Okay. So X comma DX means X data transferred to DX position. So now our DX result 83 BB also show this. Clear? Now this is not finished. Now the halt is empty. Halt means our program is finished. So this is the 5-line code. This code is addition. Suppose we use subtraction, then this data and this data subtract. Okay. Suppose this data and this data multiplication, so you use MUL. This data and this data division, so we use DI. Okay. So this is the 16-bit code, and our previously we had used 8-bit code. 8-bit code clear? Suppose 9B and 3, 2 is the addition. So this our code. Explain our code. Explain our code. Anyone? Ismail.
স্যার প্রথমটা হবে মুভ AHL আর আরেকটা যদি দেই তাহলে স্যার
যেকোনো একটা এইচ or L, not ASL. বলো move
L.
AL or must be fast data transfer to our accumulator register. Okay, these are the
Yes.
rules of our microprocessor rules. Accumulator register means A register, AX, AL, A is any. This is the 8-bit. So we not use AX. AX means 16-bit full, but no need our full. This is the 8-bit. So we need the half, any half, AX or A. Suppose we use move
AL.
AX, comma
9B.
So 9B data transfer to AX position. Okay, another move
Yes.
suppose
VH.
CH, suppose CH transfer. So CH, comma
32.
then this is the simple
Addition.
add AH, comma CH, not CH, comma AH. Okay, because
Okay.
our result transfer position is accumulator. Okay,
Okay.
accumulator is the main register, working register. Okay, main working register is the accumulator register. All data must be transferred accumulator. This code also is the shorted form, same word, just add CH direct, only one. This means we know that our must be one data is reserved our accumulator. So add CH means must be addition CH and accumulator. Okay, clear? So this your another code. No need this code. This is the easy code. Okay, CH AH, comma CH. This is the short code. Same one. Now our not finished. This is the halt. Then our code is finished. Okay. Or you transfer this register to another register. Suppose move DL, comma ACE. So ACE data transfer to ACE to transfer DL position. Okay, these are result transfer. Okay, all are clear?
স্যার HL কি এর পূর্ণরূপ কি স্যার?
হ্যাঁ
স্যার HL কি এটার ভোল্টেজ স্যার?
H means high order and low order. High order 8-bit and low order 8-bit. And AX, this is the full 16-bit. This is the 16-bit. If you use 16-bit, then AX. But if you use a high order 8-bit, this is the AX. Or you use low order 8-bit, AL. Any. This is the 8-bit, this also 8-bit. Both are 8-bit. Okay. Clear? Deba?
জি স্যার।
So this the first lab work is finished. At first discussion, our register structure, our architecture, our pin diagram, and then some program. This program is addition. Okay, replace our lab sheet. Our lab sheet program no need. Okay, this program and any program, addition, subtraction, multiplication, 8-bit, 16-bit. This is the replace our lab sheet. Okay, this is our first lab. Introducing our 8Z86 microprocessor and or 8088 microprocessor. But this code all are not 8086 microprocessor code. This is the 8088 code. Okay. So now our second lab start.
স্যার আজকের এটা স্যার কয় নাম্বার ল্যাবটা?
এটা 1 নম্বর ল্যাব। অলরেডি আমি তোমাদেরকে দিছি না?
জি স্যার।
কোথায় গ্রুপে দিলাম না? ফেসবুক গ্রুপে
জি
দিলাম।
স্যার।
দেখছো?
জি স্যার দেখছি।
Group. This. Okay. This we are using this the 8086 microprocessor. Introduction to microprocessor 8086/8088. Okay, and this not use 8086 tenor kit. We use 8088C. Okay, just change this. Okay, this is the 8086 tenor. And this is the 8086 architecture, register structure. Already this is the discussion our theory class. Okay, general purpose register, all are discussion. Okay, just we are change this program example. Okay, this code is changed. Clear? This is the 8086 tenor kit code, and just replace our code. Now this code is added our this code. Okay, this code added our this line. Okay, this one addition, subtraction, suppose this is the addition code, this is the subtraction code, just change. Okay, this code and this code just difference this part. This no need the code segment, assume code, code segment code, data segment code. Okay, then the in code in, then the full process ending. This no need. Okay, this is the one code, this is the 16-bit code, 16-bit subtraction, and this is the 8-bit subtraction.
স্যার আপনি যেভাবে দেখাইছেন ওইভাবে লিখলেই তো শুধু হবে, এগুলো তো আর স্যার লেখা হবে না।
এইটাই তো, এইটাই কিন্তু আমরা এইটুকু, এতগুলো লেখা দরকার নেই, শুধু এইটা হচ্ছে এই 16-bit subtraction. This is the 16-bit addition. Okay, and this is the 8-bit addition, but different. This is the one code, this is the at a time one 16-bit and 8-bit no need. Okay, and এটা দরকার নেই, no need this. This is the emulator, this is the using another software. Okay, this is the we are using Chener board, so no need the software. Okay, emulator software. Okay, no need this. And this your laboratory report submitted main one procedure. Okay, this is the title of page, then the title, abstract. Okay, this is the procedure. Okay, full report procedure. Okay, laboratory report template. Clear? All are clear?
Yes, sir.
Yes, sir. Yes, sir.
1 is the proceed to start another video that part for this. This are the disciplines. This is the discipline. This one video. Maybe. Suppose a letter. Very sensitive. Okay. Okay. I got to put it to a favorite. Oh, it is only simple. Okay. So now okay, explore number 2. We are start explore number 2. This is the data transmission and reception. Okay, that's the data transmission and reception. Data transmission and reception. এটা নাই করে দিচ্ছি। নাই, সমস্যা নাই, আমি করে দিচ্ছি। You are already sent this. This, okay. This is your second lab. Our second lab name, basic data transmission reception, detecting the displaying the pulses using 8255 PPI driven by 8088 microprocessor. Okay, this is your second lab. So this your lab description. This already all part is explained our theory class. Okay, 8255. This is the table, structure table. This is the this system is needed. Okay, this already discussed. Okay, now just discuss our microprocessor generic data transmission and reception. Okay, so this is the this is the sheet. Supplement can you hear me?
Yes, sir.
All are silent. This is the silent mode. Yeah, here. Not response this class. Ibrahim, yeah.
Yes, sir. Hello, sir.
Why are all are silent?
Only listen for you.
Okay. This our now our system data transmission. You know that this is suppose this your microprocessor trainer board. Okay. This is the keyboard. And this suppose this is the microprocessor 8088 microprocessor, including this another controller, another RAM, ROM. Okay, this your microprocessor trainer board. Okay, and this another IC. This is the 8255. 8255. This is the PPI. Okay, PPI. So this your microprocessor trainer board like this. This. Okay, all are clear?
Yes, sir.
বড় করা যাবে না? এটা বড় করার কোনো সিস্টেম আছে?
সেভ করে বড় করে ফেললাম স্যার। ঝামেলা হতেছে। সেভ করে না স্যার, সেভ করে বড় করে ফেলেন না, এমনি তো হইতেছে না, দেখা যাচ্ছে। সেভ করে স্যার দেখেন ওখানে
হয়ে যাবে। শিখছিলাম কোথায়? This your 808825 IC. Okay, clear?
Yes, sir.
Yes, sir.
This. Okay. Clear? So this is the 8255. This IC connect to this pin and another this the transfer this pin to. So this your this your kit, trainer kit, and this is the 8255. Okay, 8255. This is the PPI. This PPI to connect another. This is the board. This board, many board design. This is the IO board called input output board. Okay, this board also this is the design. Also the this the another PPI. Okay, PPI. This PPI and this PPI just cable connection. Data cable contact this PPI to this PPI. Then this PPI and this PPI connecting the our data cable. Then this board is connect our this board. Okay, like this. This board. Okay, this is the IO board. Clear? This is the input output board, and this is your microprocessor board. And this the PPI and this PPI. This PPI and this PPI connect the data cable. Okay. Now this board is our simple design is this. This board is this. Okay. Already এটা কাটলাম না স্ন্যাপিং দিয়ে কোথায় রাখলাম?
এই যে কাটছেন স্যার,
এই যে এখানে।
হ্যাঁ এটাই স্যার।
এটা বলছি, হ্যাঁ? তো আচ্ছা, ওখান থেকে কাটতে হবে। So this is the input output board. Now we discuss this board. This board is this the 8 LED. LED means light. Okay, this 1 LED, 2 LED, 3, 4, 5, 6, 7, 8. These 8 LED are connect the this the register. This register is contact this LED. Then this the protection, LED protection. Okay, this the some drop voltage, then the passing this LED. Okay, clear? This 8 LED. This 8 LED means this 8 light. So this the 1, 2, 3, 4, 5, 6, 7, 8. This is the 8 LED. 1, 2, 3, 4, 5, 6, 7, 8. Suppose you on this LED, this LED, this LED, this. Okay, and these two are stopped. Okay, so this means this is the our binary code. Oh, same. This is the binary code 8 and this is the 3, 11. 11 means B, and this also the 11. So BB. Our code is BB. Clear? Or suppose you are established 0, 0, 1, 1, 1, 0, 0. So if you on this LED, now our code, this called 9 and this called 12. 12 means DC. Okay, so this code is 9C. Okay, now this LED are connect the one driver IC and connect the our PPI port B port. Okay, these all are port B. So all LED are connect our port B. Okay, all are clear? This part, all LED connect or this is the fixed. If you not use this board, suppose you use this 10 board and this LED is connect our A port or C port, no problem. But this is the fixed board. This board are already established. This board is designed and this B port, all 8 pin are connect our LED pin. Okay, all are clear? So you know that our PPI programming control word, PPI control word. Sorry, our PPI control word. These are PPI. Okay, this control word already clear this our previous class. Okay, this our control word. So we are using B port. You know that this system, Mithun, you are clear this? Huh?
Yes, sir.
You already discussed our
Yes, sir.
previous
Clear,
class.
sir.
Control word. This control word, suppose your code is 1, 0, 1, 1, 0, 1, 1, 0. Now how the work? How the work? If your code is this, can you explain? Anyone? Yahya?
Yes, sir. Yes, sir.
Can you explain? You know that our architecture? কেউ রেসপন্স করো না কেন? Anyone respond this? Deva, Ibrahim, anyone respond this? Are you clear this?
Yes, sir, clear, sir, but স্যার এখানে নেটওয়ার্ক একটু প্রবলেম তো বুঝতে পারতেছি না স্যার সবকিছু। স্যার ভিডিওটা ক্লাসটা যদি একটু ভিডিও দিতেন তাহলে স্যার ভালো হতো।
সে ক্লাস ভিডিও দিলাম, তো তুমি এখন প্রোগ্রাম করতে গেলে তো এটা লাগবে, আগে এটা মনে রাখতে হবে। দেবা এটা জানো? ইব্রাহিম, আব্দুল হামিদ,
মোটামুটি
you know that our 8255 are 40 pins. Total pin 40. Okay, and you know that these are 3 port. Port A, this is the 8 pin. Port B, this also 8 pin, and port C, this also 8 pin. These are 24 pin. These 24 pins are 2 group. Group A and Group B. Group A is the 12. This port A, this is the Group A. Group A, this is the port A and port C upper part, upper 4 part. Upper, this is the 4 pin. Sorry. Upper, this is the 4 pins. Clear? So this is the Group A, and Group B. Group B, this is the port C 8 pin and lower 4 pin of port C. So port C are divide the 4 plus 4. 4 plus 4. Upper 4, this is the added the port A and upper 4, this is the Group A, and lower 4 and port B8, this is the Group B. Clear? Now,
Yes, sir.
now for the work. This D0, this the system, the D0 is control C port, lower part, C port 4 pin control. If this pin is high, means 1, then C port 4 pin are C port 4 pins. These 4 pins are all are input. Clear? If these are 0, then these 4 pin all are output. This controller is very, very important. If not clear, then our program is complicated. So must be understand this part. Okay, all are clear? So this your another, this D1 control B port. B port means B8 pin, whole 8 pin. Whole 8 pin are controlled. These are D1. If D1 is 0, then whole B port B, all are output. If 1, this port B 8 pin all are input. Okay, and this D2 is the mode selection. This Group B are 2 mode work. If these are 0, then mode 0, and if 1, this is the mode 1. These two mode work. And these four are what is these four the control the group A. So this the D3 is equal to 0, then C port C lower part all are output. If this pin is high, so C port this lower part all are input. Clear? And this D4 is control port A. Port A all 8 pin. All 8 pin, if these are 0, then all 8 pin is output. If these are 1, all are input. Clear? Why all are silent? Anyone must be respond this. Yes sir, no sir, no sir. Give the repeat please. I not clear.
Okay, sir. Okay, sir.
If you are not response, then this class is very boring. Okay, only one person talking this.
Okay, sir. Okay, sir.
Already discussed this class, our previous class, but today you not respond, then I repeat this. But why?
Okay, sir. We'll answer.
You all are not serious this class. Okay, so now these two are control this group A mode selection. You know that our group B is what 2 mode, 0 mode and 1 mode. And this group B are what 3 mode. So this D6 and D5 both are 0 then 1 watt. This 0 1 then another watt. This 1 0 this another watt. This 1 1 this another watt. Both are 0 then mode 0. Mode 0. This 0 and this one then mode 1. And now these both are 0 then 5 0. This is the mode 0. D5 1 then mode 1. But if D6 is 1, both, if D6 1, D5 0 or 1, no problem. Any 0, then mode 2, 1, also mode 2. So this, if D6 is high, D5 any, this work is mode 2. Okay, like this. Cross means very good. 0 or 1. What mode 2. Okay, and these are very, very important. If this pin is high, then all are input output mode work. If these are low, no work, this input output. Okay, so this is the control one. So
Okay,
now
sir.
And mode selection
our total 8255 work the 3 mode. 8255 work. 8255 works 3 mode. Mode 0, mode 1 and mode 2. Mode 2. These 3 mode works. Mode 0 means this is the only basic input output works. This is the mode 0. Mode 0 is only basic input output. Okay, these 3 ports, port A, port B and port C. Port B, 8 pin, port C are upper and lower and upper, and port A. All pins are what? Simple input or output. Not at a time input output. Only input or output. Suppose this is the port A, all are input. This the output. Or this is the input and this is the output. This is the simple basic input output work. But mode 1, this is the advanced part. This port B and port C, port A and port B, this is the work input and output, and C, this is the control. This control means, you know, that our walkie-talkie system, our wireless communication system, this the using our traffic controller. Okay, our police traffic sergeant use the wireless phone. This is the one-way communication. At first, one person is data transmission, then he said over, then another person is repeat. Now this person is stop or silent mode because this data not passing. Okay, this is the only one-way direction. If at a time both this channel is both work, but not at a time work. This channel is both work. At first data transmission, then data reception. Okay, but our mobile communication or this communication, I will talk to you, but anytime you respond this, another your friend responds this. So this communication is the bidirectional communication. Okay, bidirectional communication. All are clear?
Yes, sir.
Yes, sir. Yes,
The
sir.
advanced communication, bidirectional communication. So this is the mode 2 format. Okay, so this mode, our group A, group B only work these 2 modes, and group A work 3 modes. So these are controlling this. If D2, this is the control our group B, what's the mode work. If D2 is 0, then group B work mode 0, and this the 1, then this group B work mode 1. Okay, all are clear?
Yes, sir.
And these 2 are control our group A mode selection, because group A is 3 mode work. So 1 pin is not possible 3 work. 1 pin only work 2, 0 or 1. Okay, high or low. So this is the 2 pin. You know that 2 pin are work combined work 4 work. 0 0 0 1 1 0 1 1. Okay, so these both are 0, then mode 0. This 0 and this 1, this is the mode 1, and these both are mode 2.
Okay, sir.
Okay, all are clear?
Yes.
So suppose we need this lab we use B port. Okay, our diagram already, this our diagram. This diagram we use only B port. Okay, port B all are output. Port B all are output, because all the LED high. So all are this port B 8 pin all are output. So our code, now our code is must be this pin is high. If not high, then our IO mode selection not work. Okay, so must be, if use IO mode input output selection, then must be D7 is high. And our program B port is output, so this pin must be 0. If this pin 1, then Port B all are input, but our port B all are output needed. Clear? All are clear? Because our tenor board, all B port is connect the LED output. So must be B port is needed the output. Clear? So B port all are output. So must be this pin is low, and this the work group B port work the group B. So group B hot mode mode selection must be needed mode selection. So just we are use basic mode, no problem. We use 0. Then this is the basic mode. Okay, mode 0 mode selection. Okay, 0 mode selection, and port B all are output. Okay, so must be these two is low and this pin is high. Then another all are high or low, no problem, because all pin are not connected our lab. All are free, no connection. Okay, all are no connection. Only connection this 8 pin. Clear? All are clear? So these 3 is mostly important. 1 0 0. Now these all are 0 or 1, no problem. Suppose we use 0. All are 0. So our hexadecimal code, this 4 means 0 and this 4 means 8. Okay, so our hexadecimal code is 80. So all are clear?
Yes, sir.
Okay, so now we start our lab. Okay, so this part is finished. This our input output board. Input output board 1. Many boarded are using our lab. If you just change this board and data cable, just connect our this the board change, another board use, then only connect our microprocessor to this another board, connect this the data cable. Okay, so now we use only output function of B port board, IO board 1, using the IO board 1. Okay, our lab. So now our programming, this our programming. So just drop this. It's not okay. So now if you understand this section, then our program is very easy. This is the flow chart. At first we are start, and must be needed our board. You know that our program, this is the microprocessor and microcontroller 8255. This 8255 only connect the 8 pin of port B. Okay, all port B connection the LED. Okay, this is the hardware, all connection the LED. So port B is our program must be port B output, and group B mode selection mode 0. Group B must be mode 0, this output means this pin is 0, and mode 0 means this pin is also 0. Okay, this is the, you know that this is the D1 and this is the D2. Okay, and this work, our code is 80. Okay, already finish our this part. Now this is the start. Set 8255 mode 0 and port B output. This already set this. Okay, so this function is, our code is 80, and this part is finished. Now our program, just short note, our program move L register is 8-bit data transmission. We are already assigned our how the LED on. This your suppose this 8 LED, 2, 3, 4, 5, 6, 7, 8. This 8 LED, we need the these all are high and this low, this 2 is high. Suppose this your code. Okay, you need this first 2 LED high and last 2 LED high. So our code is this, the 12 means C, and this the 3, the C3. Your code is C3. So your code move L comma C3. So C3 data transfer to L register, then out means output port, transfer output port. You must be needed output port address. This is the output port address. This port address is fixed. 11 is the output port address, and 13 is also output port address. So this is the port address 13 comma L. This is your program. This data transfer to L register, then L register to transfer our output port address, then halt. This 3-line your program. Okay, this move data to L register. This is the data to transfer L register. This line, and now write L to port B. This is the L2, this is the port B register address. Okay, so this L2 register address data transfer output. Then your program is finished. But these parties must be added. This line, these are 2 lines. Move at first L register comma 80. This 80. This means this 80 data transfer to L register, then our another code output 13 comma L. L register to transfer this data transfer to 13 number port, then these 2 are controlling this part. Okay, all are clear? These 2 are controlled. These 2 line is controlling line. So 80 data transfer to L register, then L register to data transfer 13 number port. Then 13 number port means this 80 means already discussed. 80 means our mode 0 is selected of group B, and port selection of B port is output. Okay, 80 means clear. So this your 5-line code. Only these 2. Violent.
Another big thing was the Malaysia guy. Yes.
Who this person? Yeah, yeah.
Yes, sir. Yes,
Okay,
sir.
thank you. So all are clear?
Okay, sir.
Yes, sir. Yes, sir.
So this your 5-line code. This first line means this data transfer to L register, and L register to transfer 13 number port. This means our mode selection B port 0 mode, and our group B B port is group B is out mode 0, and port B is output. And now just only your program is changed this this part. Suppose we need all LED high, 8 are high. So our port, this 4 means F and this 4 means also F. So our port is FF. This is FF. Just change this C3, change FF. Means all are high. Suppose we need 1 0 1 0 1 0 1 0. So this means A and this means A. Just we change this AA. Okay. This is the data transfer register to our microprocessor to input output port. Okay.
Okay, sir. Okay, sir.
Okay. So today just only data transfer part is complete. The next day data reception part is clear. Okay. So today our class is finished because this class is very boring class. All are not response this class. All are silent mode. So
No fair. No fair, no.
I'm not interested in this class.
It's trust, sir.
Okay. So all are clear.
Yes, yes.
Okay. So just today present this roll 1. Roll 1.
अच्छा अच्छा दिवा अच्छा
Okay. Today 19 तारीख में 19. So roll 1 Deva, roll 2,
जी सर
roll 2 present.
yes sir
Who?
yeah
Roll 2,
अच्छा
roll 2 Abdiaziz. Okay.
yeah that's
Roll 3 Monir Taskenai.
না স্যার আসতে মনে নাই
Roll 6 also Rizvi আছে তো.
রিজভি স্যার ও বের হয়ে গেছে মনে হয় ফোনে চার্জ শেষ আমার ফোন দিয়ে বলছে বলার জন্য আপনাকে
Roll 9 Ibrahim আছে. Roll 10 Ismail আছে. Roll 12
Hello, sir.
roll 12 কে
Absent.
স্যার ও তো প্রথমে ছিল এখন নাই
Hello, sir.
কে নাম কি roll 12
স্যার আব্দুল্লাহ
আব্দুল্লাহ তো ছিল. Roll 14 আছে ইয়াহিয়া roll 14. ওকে.
Yes, sir.
সাকিব তো আসে না. 17 ছিল 18 আছে তাই তো.
Hello, sir. Hello, sir.
Yes
10 আছে, sir. 10 আছে.
yes 10 already present. No problem.
Okay, sir.
Only 2% this day absent, Sakib and Monir. Okay, so today our class finished. Thank you very much.